Okay, ladies and gents, in this video we're going to start looking at a molecular view or a microscopic view of what the electron cloud really looks like and how many different electrons you can fit in the different sublevels of the atom. That being said, this illustration before you is as if we took an atom and started stripping off all the different layers of the electron cloud and then laying them flat out on this piece of paper. And when we do that, we're going to notice that there are 4 different sublevels inside the atom. Okay, 4 different sublevels. In the center of each one of these orbitals here, I put a black dot, and that black dot represents where the nucleus would be for each one of these different atoms, okay? So that being said, let's start with the first sublevel, and that is the S sublevel, okay? This very first one right here. The S sublevel has only one type of orbital in it, and that's called the S orbital. And the S orbital has a spherical shape, just like this one. It's not important that you know the shapes, you just need to know how many electrons are in each sublevel. Because the S sublevel has only one orbital in it, that's the S orbital, and each orbital can hold 2 electrons, this means that the S sublevel has 2 electrons total. Alright, the S sublevel has 2 electrons. You can only fit 2 electrons in the S sublevel. Then you have to move on to the next sublevel, okay? And the next sublevel is the P sublevel, which has 3 different types of orbitals in it, okay? More specifically, it's px because that orbital is oriented along the x-axis, py because that orbital is oriented along the y-axis, and then pz because that orbital is oriented along the z-axis. Because there are 3 different types of orbitals, and each orbital can hold 2 electrons, that means the p sublevel total can hold 6 electrons. Once you fill the P sublevel with 6 electrons, you then have to move to the D sublevel, which has 5 different orbitals in it. Now, I'm not going to get into the names of each of those orbitals because this is where it gets really complicated. So you don't need to know the shapes of the orbitals, you just need to know how many electrons are held in each sublevel. Because there are 5 different orbitals in the D sublevel, and each orbital holds 2 electrons, that means in total the D sublevel has 10 electrons total. Once you fill the D orbitals with 10 electrons, you have to move into the 4th and final sublevel, and that is the F sublevel. And there are 1, 2, 3, 4, 5, 6, 7 different orbitals in the F sublevel. So that being said, with 7 total orbitals, each orbital holding 2 electrons, you get a total of 14 electrons in the F sublevel. Okay. Alrighty, again, it's really important that you know these numbers here. And in fact, these numbers help dictate the shape of the periodic table as you're going to see in the next video. Now again, I told you that this image right here of all these different orbitals is as if we took the atom and stripped off all the different layers and we broke it down layer by layer. In reality, what happens to these orbitals when they make the electron cloud is they actually stack on top of each other. So for instance, if we had an s orbital right here, the next orbital would be the p sublevel, so the p sublevel would stack right on top of the s sublevel like this. And I'm drawing the p sublevel like this because that's all 6p or all 3p orbitals stacked on top of each other. And again, the nucleus is right there in the center. Okay, you could then stack another s orbital on top of that, for instance an s orbital on the second energy level, and it would look like this. And then you could also stack p orbitals from the second energy level on top of that, and then it gets to be a real big mess. In fact, it almost gets impossible to draw it. But this is just to show you that the orbitals literally stack on top of each other in the atom. And then in this photo right here, we just split all of the orbitals apart. Okay? Alright, stay tuned for the next video.